example. Okay, let's say, for example, a horizontal line looks like this. Okay, so when I talk about the gradient of horizontal line, remember gradient is just rise over run. Okay, so horizontal line, there is no rise, but there's some run. So therefore, the gradient is 0. Okay, for a horizontal line. Which means, in other words, for a horizontal line, it's always of the form y equals to a certain constant number, correct? So when I find the gradient itself, which is dy dx, okay, I actually get a gradient of 0. dy dx equals to 0. Okay, and it's also because of this, the rise over run part. Okay, the line function itself, y equals to mx plus c. The gradient, we know it as the m over here. Okay, so therefore, when I write it in this form, it is essentially this. Okay, so keeping this in mind, later on, you all will know how to systematically find what is dy dx. Okay? Okay, now, here, the way you all write is also very important. When you have y equals to a certain function, let's say y equals to 7x. Okay, when they ask you to differentiate, then you can write dy dx equals to 7, for example. Okay, differentiate y with respect to x. That's what it means. Okay, so this one is in terms of x. Okay, however, if I never write it in an equation form like this, y equals to 7x, I write it as just an expression, 7x. I tell you to differentiate 7x with respect to x. Then it is differentiating 7x with respect to x. So it's just d dx without the y. Okay, the y comes in only when you have an equation like this, y equals 7x. So dy dx will be 7. Then differentiating this 7x, you will get 7. Okay, later on I will tell you why for this. Okay, so when I tell you to differentiate 7x with respect to x, you cannot write it like that. No such thing. Okay, so when you write dy dx, there shouldn't be the expression attached to it. Okay, so take note of the way of presentation. Okay, let's say now instead of writing as y, I write it as fx. Function of x equals to 7x. When you differentiate with respect to x for these kind of function form, you put it as okay, this is what we call prime. So f prime of x means I differentiate the function. Okay, this will give me 7. Okay, so 3 different ways of writing. So depending on how the question gives you. Differentiate this function with respect to x. Okay, so it's just like y. When I write it as differentiation, it's dy dx. Okay, if it's just the expression 7x itself, I'm differentiating 7x with respect to x. If I give you in this form, fx equals to 7x, then when you differentiate, you put in this prime question. Okay, so 3 different ways of presenting. Okay. Okay, so be careful of the way they ask you to present. Okay, now we go to the rules themselves. How do I actually differentiate different types? Okay, differentiate constant number, differentiate linear terms, differentiate power terms, and so on. Okay, so the first rule is what we call constant rule. When you differentiate a constant number, you will always get 0. Okay, so no matter what the constant number is. So let's say if I want to differentiate with respect to x5, I will just get 0. Okay, it's the same idea as when you have a horizontal line, and then when you find the gradient is 0. Okay, same thing. When you differentiate with respect to x pi is not an unknown. Pi is a number itself, a constant number. So you will also get 0. Okay, so whenever you differentiate a constant number, you will always get 0. Okay, so that's the first rule. Okay, what about when you differentiate? Okay, linear terms. Okay, let's say ax. Okay, this one usually we use the power rule for both of this. Okay, what is power rule? So this one is just ax to the power of 1, right? The a is just some constant number. So you always bring down the power, reduce the power by 1. Okay, drill this into your brain. So I bring down the power, 1 times a is just a. Reduce the power by 1. 1 minus 1, 0. Anything to the power of 0 is 1. So that's why the x is gone. Okay, so in other words, whatever x, right? Let's say, for example, differentiate 4x, I will have 4. Differentiate 5y with respect to y, I will have 5, for example. Okay, so now what happens if I'm differentiating this entire thing? Okay, so here I differentiate term by term. So when I differentiate this, negative 7x, I will get negative 7. Okay, when I differentiate a constant here, I will get 0. So therefore, when I differentiate this entire thing, is just negative 7. Okay, now what happens when I have this kind of expression? Okay, later on you will learn something called the quotient rule, meaning when you have something divided by something. However, you always try to simplify what you can first, right? So when your denominator is just one term, okay, let's say for example x here, and then you realize on top over here, I can also factorize out an x. Okay, so what I will do is before I differentiate, I haven't differentiated yet, so I still have to put this down. I take out the x, this one becomes 5x minus 8. At the bottom, still got the x. Once I put it in this form, I can simplify by cancelling the x away first. Which means differentiating with respect to x for this is the same as differentiating just 5x minus 8. Okay, so now same thing. When I differentiate 5x, I will just get 5. When I differentiate constant 0, so it's just 5 essentially. Okay, now the power rule also applies to any other power. Okay, so let's say for example x to the power of n. I bring down the power, then I subtract the power by 1. Okay, so drill this with your brain. So for example, a very simple example. Differentiate x cubed. I bring down the power, reduce the power by 1. Okay, so that's it. I drill this chant into your brain. Okay, what happens now if I have these 3 different terms? Okay, term by term first. This term. Here, the power 5 is over here. I bring down the power such that the 2 is multiplied together with the 5. So it becomes a 10. And then I reduce the power by 1. So it becomes 4. Okay. Then now for the second one, same thing. If you want to continue using the power rule, I bring down the power, reduce the power by 1. So it's just x to the power of 0, which is gone. Okay. Then constant, don't need to care. Whenever you differentiate constant, it's just 0. Okay, so that's it. Okay, here, when you have 1 over x squared, this part, always put it in power form. Okay, so that you can use the power rule to differentiate this. So instead of writing it this way, I'll write it as d dx. Okay, remember in your indices you learned before, right? This can be rewritten as x to the power of negative 2 when I bring it up. Okay, so using the same logic, I bring down the power, reduce the power by 1. So it becomes this. Okay, let's say if they ask you to leave your answer in positive index form. Okay, then you have to put back the x cube down like this. Okay. Okay, same idea over here. Here, I don't want it to be at the bottom. Okay, so if it's at the bottom, you put it up. Okay, I am differentiating 3x to the power of negative half like this. Okay, so same logic. This one power, I can use power rule, bring down the power, so it becomes 3 times negative half. Okay, so negative 3 over 2. Reduce the power by 1. Okay, so minus 3 over 2 like this. Okay, minus half minus 1 is minus 3 over 2. Okay, then minus 3 over 2, this one bring down if you don't want the negative. Okay, so it becomes x to the power 3 over 2 like this. Okay. Okay, so far you only learned the power rule first, right? Okay, now for this one, again, I see if you have just one single term at the denominator, okay, simplify what you can first. Okay, separate them out because you don't know the quotient rule yet. I cannot deal with a fraction like this. Separate them out into individual single terms. Okay, so this one becomes differentiating with respect to 5 root x over root x. Okay, I split them up into two different terms. Plus 1 over root x. Okay, so again, you have only learned power rule so far. Okay, the first one, you can of course simplify by cancelling this one away. Okay, so this portion here becomes just 5. This one, however, when you have a square root, okay, recall in indices you learned before, right? This equals to a to the power of half. Okay, or in other words, in general, inside, outside like this, right? It's just equals to a to the power of in over out in general. Okay, so that's why cube of a, for example, cube root of a is just a to the power of 1/3. Okay, so using the same logic here, instead of writing it as root of it. Oh, okay. Oh, okay, carry it. Okay, so plus x to the power of negative half. Okay, so differentiate constant 0. Don't need to write. Differentiate this one, bring down the power, reduce the power by 1. Okay?
The power x power minus half, then you bring the
So you get minus 3 over 2. Right?
okay.
Okay, this kind of initially when you're not comfortable, type into a calculator. Okay, so just like minus half minus 1 equals to what? Okay, then you will have this. Okay, so another technical difficulty. Oh. Okay, so here again, if you don't want negative index here, put it down together with the denominator. Okay, so that you can remove the negative power. Okay. Let me just check on something first. Jenny, just now your side can see my workings or not?
Yeah.
Oh, can, right? Okay, anytime, right, you cannot see or cannot hear, you WhatsApp me. Okay, I will check the WhatsApp location. Okay. Now what are we trying to find? The gradient function. The gradient of the original function. Okay, later on you will know how to use it in the application. D just means differentiation with respect to x. So after you differentiate everything, you don't need to write this. Okay. So here, same thing. This one, okay, later on you will learn something called the product rule. Okay, but always try to simplify what you can first. This is just normal multiplication by distributive law. Okay, so all you have to do your rainbow method. Expand all of this out into singular terms first before you differentiate each of them. Okay, so here, okay, I will put this as a bracket first. This one multiplied to this. Okay, 1x on top, 1x at 2x at the bottom here. I cancel 1 here, cancel 1 here. Okay, so all you are left with is 8 over x when you multiply this. Okay, then when you multiply this to this plus 4x squared, this to this one, plus 14 over x squared. Okay, then 7 to x plus 7x. Okay, so here you can differentiate one by one after you change it into the power form first. Okay, so all the ones at the denominator, put it up with a negative power. Okay, then this one plus 4x squared plus 14x to the power of negative 2 plus 7x. Okay, then now, okay, do the chant again. Bring down the power, reduce the power by 1 for each of them. Bring down the power, this becomes negative 8. Reduce the power by 1. Same thing for this, this, and this. Okay, bring down the power, you have 4 times 2, so 8. Reduce the power by 1, so x to the power 1. Here, same thing. When you bring down this power, it's negative 2 multiplied by 14. So negative 28. Then x to the power of negative 3. Here, be careful. Minus 2 minus 1 is negative 3. Okay, then this one, same thing. Bring down the power, reduce the power by 1, which means you will just end up with 7. Okay, then if you need to write it in terms of positive index form, put it down. So it becomes this. Okay, then the x to the power of negative 3, bring it down, so it becomes x cubed, then plus 7. Like this. Okay, so before you start differentiating, let's say you are just simplifying, right? You must still add in the ddx part. Okay? So make sure you only remove it when you already differentiated. Okay, can Jenny so far can follow?
Yeah.
Okay. So this one is just the technique itself. So now I'm going to tell you what it means generally. Okay, so just now briefly I say, right, okay, your dy dx is actually a gradient function for your curve. Okay, so because for a curve at every different point, your gradient is different. Okay, so that's why it's a gradient function. Okay, so say for example, y equals to x squared is my original curve. Right? So when I put dy dx, what I will have is I bring down the power, reduce the power by 1. So it is a function. I don't have an exact number, right? Why? Because, right, when I sub in the x value at different points of my curve, I will have different gradient. Okay, so essentially, let's say, for example, y equals to x squared, right? Let's say I will have this like this. Okay, so when I put dy dx equals to 2x, it means when I sub in all the different x values at different points, so let's say here, my gradient will be going downwards until this point where it is horizontal, and then it goes up, up, up like this. Okay, so let's say, for example, at this point where x equals to 0, okay, my dy dx, which is 2x, will just be 2 times 0, which is 0. Makes sense, right? At the turning point here, my gradient is a horizontal line, so the gradient is 0. Okay, so for this dy dx, it is a function of x simply because at different points of my x, the gradient here will just be found by substituting the x as the x values here at each of these different points. Okay, so that's why this is called gradient function. The x values into the dy dx, correct? So this dy dx function will work for at all points of x, the gradient of the curve at all points of x. Okay, so some other ways of saying the gradient function, right, is also tangent. Okay, so you can view tangent as dy dx. Okay, then you all learned before these normal lines. If you all have done coordinate geometry before, normal and tangent are basically 90 degrees to each other. Okay, so in other words, okay, the gradient itself for normal versus tangent will be -1 over the original gradient. Which means, in other words, here, right, once I find a gradient at this point over here, -1 over the gradient at this point for tangent will be the gradient of the normal line. Okay, so because tangent line, normal line, they are both lines, which means it can be written in the form y equals to mx plus, where the m is the gradient at the front. Okay, so now I'm talking about a certain point here. Okay, so like I said, dy dx, once you sub in the x value here, you get a constant number, which essentially is the gradient of the tangent line at this point. Okay, so to find the gradient of the normal line, you just take -1 over the gradient of the tangent. Okay, so this one later on we'll touch more on this in the application part. Okay, so now let's say, for example, you are given this function y equals to 2x cubed. Okay, then dy dx. Okay, whenever you are given in this form, y equals to some x, right? Then you can write it in this form, dy dx. Differentiate y with respect to x. That's what it is. Okay, so all you have to do, bring down the power. So you get 6. Reduce the power by what? Okay, by your power rule. Okay, and then if, just now like I said, if you're given in a different form, fx instead. Okay, when you differentiate, you put it as f prime x. Okay, so different forms of presentation. But before you differentiate, make sure this one you put it in a form that's easier for you to differentiate first. Okay, so this root x, it is x to the power of half. Okay, then I put it up, so it becomes -4 x to the power of -half like this first. So I put it here first because I haven't differentiated. I'm just re-expressing this first. Okay, then now, okay, the chant comes in, bring down the power. -4 times -half, you will have a +2. Okay, then reduce the power by what? -half minus 1 minus 3 over 2. Okay, then here, if you want to put it in positive power form, put it down. Okay. Okay, now let's take a look at some sort of application question first. The gradient of the curve at this point is 22. Okay, again, remember whenever they talk about gradient of a certain curve, I use dy dx really. Okay, so but dy dx will only give you the gradient function at a certain point. Okay, what is important is the x basically, because when you dy dx, the function will be in terms of x. Okay, so the y here is not important. Okay, so here, notice the gradient of the curve. So first thing you should do is dy dx first. Okay, so what you do here is you bring down the power, reduce the power by 1. Here you plus a lor. When I bring down the power, reduce the power by 1. Okay, however, what you realize here is there's an additional a here, right? correct? Instead of the usual number form. Okay, so what should you do first? No, I'm talking about, okay, this one bring down the power, reduce the power by 1 already, right? This one also, the power is just 1, you bring down the power, reduce the power by 1. Anything to power 0 is 1, right? That's why there's a 1x. Okay, so you realize this first part here, I will have additional unknown here. Okay, keeping this in mind, here I have at this point 2, 7 is 22. The gradient at this point is 22. So based on the gradient function, when I plug in x as 2, okay, so when x equals to 2, my gradient itself will be equals to 16 times 2 plus 8. Okay, which is equals to 32 plus 8. And then they tell me this gradient is supposed to be 22. Okay, so this just means this one equals to 22. Okay, the gradient at this point is 22. So this portion here is supposed to be 22, which means you form your first equation, 32 plus 8 equals 2. So A will just be 22 minus 32. So negative 10. Sorry? In a sense, you can view it that way. Okay, so because this is a gradient function. Okay, but at this function, of course, at different points, you will have different values of x. So that's why at this point, your gradient itself is 22. It's given to be a number. So once you plug in the value of x here, make it equals to 22, you can solve for the other. Okay, then next, also have the value b, correct? How do I find the value b? The value b only appears in the original equation. Okay, and the original equation, what do I know already? The value of a, correct? Plug it in first. So I have y equals to 8x squared minus 10x plus b. So in this case, when I have this equation, how do I solve for b when I have one equation and technically 3 unknowns? Correct. Okay, so in order to solve for this one unknown, I need to plug in the value of x and y. Okay, and which value do I know? This one. This value itself is on the graph. Okay, so I plug it in. So when x equals to 2, y equals to 7, plug it into the equation here. Then you will be able to solve for it. Okay, so you have 7 minus square. Okay, then you will have b equals to negative 5. Okay, so therefore a. Okay, so whenever they talk about gradient of a certain curve, straight away you all must think of dy dx. And dy dx is not enough because it's just the gradient function, which works for at every point of the curve, the gradient. So to be able to fix the gradient at a certain point, you need to sub in the x value at that. Okay, can? Okay, so that's the idea. Okay, now I'm going to talk about another rule, okay, which is slightly different from your power rule. Okay, what happens now, if you have something like this? Okay, so this is what we call the chain rule. Okay, so when I have a power attached to something plus something, for example. Okay, so here my unknown is inside, right, the x. So this is what we call the chain rule, where I first deal with the power outside. I bring down the power, reduce the power by 1. Okay, but notice the inside over here, I can also differentiate, right? Then I need to multiply by the differential of the inside. Meaning first you see I bring down the power, reduce the power by 1, I will have this part. Okay, then I have to multiply by differentiating the inside. So when I differentiated the inside, a, x, I differentiate, I get a. B, I just get 0 lah, which means I need to multiply by. Okay, so in other words, generally, bring down the power, reduce the power by 1, multiply by the differential of the inside. Okay, so that is for the chain. Okay, so now let's do a few examples to get familiarized with this. Okay, so here, instead of expanding out into singular terms, which will waste a lot of your time, use chain rule to do this. Okay, so I bring down the power first, reduce the power by 1, and then I multiply by the differential of the inside. Okay, when you differentiate 3x plus 8, you will just get 3. Okay, because when you differentiate 3x is 3. You differentiate 8 is 0. Okay, so you multiply by 3. Then here simplify what you can. 5 times 3 is 15. Then this will be your answer. Okay, do not go and expand everything out using binomial theorem or whatever, and then you differentiate them like that. Right? That's going to waste a lot of time. Okay, so use chain rule for this. This power applies to this entire thing, correct? So I deal with the power outside first. I bring down the power, reduce the power by 1. I get this right. Then I still have to remember the inside part I can differentiate, right? 3x plus 8. I differentiate this, I get 3. So I multiply by 3. Okay? So same thing, this one chain rule as well. This one, I bring down the power first, reduce the power by 1. I multiply by the differential of the inside, which is 2. Okay? Then you simplify, you get 14 times of 2x minus 5 to the power of 6. That's it. Okay? So what is the difference between this and the power rule, right? Okay, the power rule essentially is the same idea as chain rule. Okay, so I'm going to briefly go back to the power rule for a while so that you all can understand the rationale. So let's say if I'm dealing with power rule, for example, this one, I can also view it as like that, right? I bring down the power, reduce the power by 1, and then I differentiate the inside. I differentiate x is just 1. So that's why it's just 3x. So it's actually the same idea as chain rule also. Okay? So that's why our chain rule, power rule very similar. So you just have to remember, you need to always remember to differentiate the inside part as well. Okay? Okay, now things like this with a square root one. Okay, remember, always put it in power form. Okay, so this one will be 6x minus 9 to the power of half for square root. Okay, remember you haven't differentiated yet, so you still have to put in the dx here, differentiating with respect to this. Okay, so now comes your chain rule. I bring down the power, reduce the power by 1. Okay, then don't forget the inside part. Also have to differentiate. So I will get 6 when I differentiate it. Okay, then here, a bit of things to take note. 6 times half, I can simplify to 3 first. Okay, then notice this one is a negative power, right? I put it at the bottom. However, power half, right? Usually, some schools will require you to put it in the root form. Meaning you put it back as this. Okay, you bring it down, it will be a positive power half, and then you put it back in the square root of 6x. Okay, sometimes some schools are okay with just putting it as power half. Okay, bring down the power, reduce the power. Minus 1 is minus half. Okay, so initially, after you get used to it, you will get it very fast. Initially, you press the calculator, minus 1 equals 1. Okay? Okay, then you'll get this. Okay, similarly for this one, also re-express as the power form first. Okay, so you will have 4 minus 3x squared whole thing to the power. Okay, then bring down the power, reduce the power by. Okay, the inside part, here you have to be careful. When you differentiate 4 is 0, right? When you differentiate this part, it comes with the negative. Okay, so when you bring down the power, okay, this one, when you differentiate this part, okay, here I'm going to jot it down at the side first so you all can see. Okay, so when you differentiate just this negative 3x whole thing square, right, you will get, bring down the power, so negative 6, reduce the power by 1 like this. Okay, so therefore you should multiply by a negative 6x. Okay, when you differentiate the inside. Okay, so meaning you need to use the power rule to differentiate the inside part here. Okay, then now you slowly simplify what you can first. Negative 6x divided by 3, you get a negative 3x. Okay, then this one, you put it down at the bottom. Okay, so it becomes square root of 4 minus 3x squared. Sorry? When is it minus 3? If it's negative 3x, then you bring down the power, reduce the power, right? Now it's negative 3x squared. When you differentiate that, you bring down the power, negative 3 times 2, 6, right? Negative 6, right? Reduce the power by 1, so still got the x. Okay, so that's why. So this one, within this, it's just the power rule. Okay, Jaylene, so far can understand?
Yeah.
Okay. Okay, for today, I'm going to stop here first. Later, if I have more time, I may go through product rule. Okay, then I'm going to print the tutorial for you all to try out first. Later, I will. I'm going to bring my calculator. You text yourself. Okay, take some time to digest the notes first before I pass you all the tutorial to try out. And Jenny, right, you have the tutorial review already, huh? Can you try out the first two questions first? Okay, then at every question you finish, send me your working. Okay, so those of you who got your tutorial already, okay, let me select a few for you all to try out. Yes, also remember. Okay, so here in your tutorial,